Scala Meetup, and we are again hosted by Demandbase. Our host Eric, thank you guys for hosting us, and my co-organizer Salar is gonna run the show tonight. Salar put this together. Thank you, Salar. I just want to say a few words about the theme tonight. We have the GraphQL talk by Pierre and the type systems talk by Bill. We at SF Scala and Scale, by the way, I think we're the pioneering Scala community to share the GraphQL ideas. We had, I think, an invited talk about GraphQL when it just kind of hit the market. It was always positioned as a typed and performant a system which is obviously better fit for Scala than JavaScript, and we've been promoting it since then. I think it took hold as a pretty much accepted middleware in the backend at Twitter and at Medium, and there is a huge interest now into it. Everybody is using it, so it's a full stack technology. Super excited to see the talk about it. Thank you, Salar, for organizing it, and Pierre for speaking. Pierre is coming from Seoul, so really amazing. And Bill, co-author of the Scala book, has an update and a talk about Scala. It's always great to have Bill. So I think we have a fantastic meetup tonight. Hope everybody enjoys it. I know it's Friday, it's unusual, so let's see how this goes. Already 40 participants, exciting. And with that, I thank Demandbase and hand it off to Salar, my co-organizer.
Hi, everyone. Thank you for joining us for this month's Scala SF Scala Meetup. To start the ball rolling, here's the agenda for the evening. Demandbase have kindly sponsored and provided the Zoom for this event. So we're going to start off with them just telling you a bit about what they do. And please, everyone, thank them for hosting us. Then after that, Pierre, like Alexei said, live from South Korea, will do his talk on his fabulous library, the Caliban FP GraphQL in Scala. And then, of course, after that, Bill Venners, the author of the Programming in Scala book with Odesky, is doing a talk on with understanding Scala's type system. He is actually based in San Francisco, so he will be coming live from the Bay Area. So without any further delay, over to Eric to tell us all about Demandbase.
Hello, thank you. Yeah, basically, what we're doing is we're just hosting this on Zoom. We're using our enterprise license with Zoom to be able to handle all this traffic and to record it and to provide it for you afterwards. In a different world, we'd be offering you beer and pizza and hosting you on site. So thanks everyone for attending. Just a few words about Demandbase. We're a late stage startup. Basically what we do is we process the world's business data to help marketing and sales organizations with their account-based marketing needs. And that includes a large fraction of our customers are Fortune 500 companies. And basically we process massive amounts of data, up to 5 petabytes a day, 10 billion events per day. We have over 50 machine learning models in production. We use Scala, we use MLlib, we use TensorFlow, BigQuery, and we really have an unbelievable data engineering and data science team. And unlike other companies, we don't put our teams into buckets. We believe that the best organizations, the data scientists, the product, data engineering all work together. So we have data scientists with PhDs that get trained by engineers, and we have engineers that get trained on data science. And I think not many companies can say this, but our VP of product has a PhD in machine learning from Stanford. So that just sort of gives you a sense of where we're at. And we believe that really to build the next generation of AI-driven and data-driven, account-based marketing and sales products, we need engineers with proclivity for data science and machine learning. And so if you want to learn more about Demandbase, please reach out to me or the organizers of this meetup, and we can chat. But we're always looking for experienced talent. So this time we don't have any speakers like last time, but we hope in the future to be able to field some other speakers, just to give you a sense of what we're doing with Scala, what we're doing with big data, machine learning at scale, and that's pretty much all I wanted to say about Demandbase. Thank you, Salar and Alexei, for organizing this meetup, and thanks everybody for joining.
Thank you, Rick. Really appreciate everything. Helping us with running the Zoom and all the help to facilitate this event. Thank you so much. And like Eric said, please reach out to me if you need an introduction to Eric at Demandbase or information. And he's also on the Slack community that we have. Great. So without any further delay, if I can introduce you to Pierre Ricadat, who's kind enough to do his talk now on his library, Caliban, all the way from South Korea. Over to you, Pierre. Thank you.
Hey, so let me share my screen first. Okay. All right. Can everybody see my screen? And can you all hear me?
Yep, perfect.
Okay, good. So, so today I'm going to talk about a library called Caliban that I created about 6 months ago. So this is a library for creating GraphQL backends and frontends in Scala. The frontend bit was added quite recently. So I'm gonna cover a bit all the features that are in Caliban. I'm not gonna cover too deeply some of the topics, but if you're interested, I wrote some blog posts about everything that I'm gonna talk about in this presentation. So if you wanna have more examples and so on, you can refer to the blog post that I will link at the end of the talk. Here is more like a tour, an introduction of what it can do. Okay, so who am I? My name is Pierre. Maybe you've seen my avatar or my GitHub handle somewhere. I'm French, but I live in Korea. So I'm calling from Seoul. It's 10 a.m. here. I have been contributed to Zio and a bunch of Zio sub-projects in the ecosystem, and I created Caliban last year. So first, let's start with GraphQL. Maybe not all of you know exactly what it is, so I'm just gonna briefly introduce it so that everybody can follow. So GraphQL is a query language APIs. It was created by Facebook a few years back, and it's getting more and more traction. So a query language, what it means is that it doesn't enforce you to use some technology on the back end or in the front end. This only defines how the client and the server are going to communicate together. So in a way, it's more similar to REST, for example, but then you can develop your application in any programming language. So what's special about GraphQL is that the server exposes a type schema, which is actually a graph. So what this schema is that it lists operations that are available. There are 3 types of operations: queries that are just for getting data, mutations for modifying data, and subscription to be notified of data from the server. So a schema lists operations, and then for each operation, it returns a type, and then each type is clearly defined with some fields, and each field returns other types, and so on. So it builds a whole tree like that with everything that's available. And then the client, when they do a query, a GraphQL query, they request only what they want. So they can ask for several root fields, and then for each field, they say which field in the response they expect, and so on. So the advantage compared to REST is that if you have a web page, and when the web page is open, you need to do multiple REST API calls to get profile, get preferences, get whatever. With GraphQL, you can get everything at once. You can just do one query and say, I want the profile, the preferences, and this. And another advantage is that you don't need, with REST, you cannot really decide what you want, right? The endpoint will return everything that it has. So it means that you end up sometime gathering from the DB or so, serializing to JSON, and then downloading on the client side, potentially a lot of data that you don't need. So with GraphQL, you can say specifically what you need, and the server will only return that. I have a short example, small video example to show you the experience doing a GraphQL query. Just one thing that is quite nice is that because GraphQL exposes a typed schema, so we know all the types in advance, you get some documentation for free. Tools like this one, GraphQL, and also Insomnia, Postman, Altair, they are able to introspect the API and show a documentation with all the types and so on. And it's also able to give you some auto completions and so on. So that's something pretty nice compared to REST as well. So here is a little example. Okay. So you can see that when you start typing a field name, it shows the autocomplete because it knows the fields that are available thanks to the schema. If you type a field that doesn't exist, it will tell you, like here. Okay, and then you send your request, and you see in the response that all the fields that you get are the fields that you asked, title and opening row, and you can see also the auto-generated documentation from the schema. So it makes the experience pretty nice, especially on the client side when working with GraphQL. All right, so why did I decide to create a GraphQL library in Scala? There is another library in Scala that exists that's called Sangria. It's a pretty good library. It was there for a long time from I think the early days of GraphQL. So the reason I decided to do a new library was that I had this REST API with a lot of endpoints, over 100 different endpoints, and I wanted to port that to GraphQL to get some of the advantages that I mentioned before. And the problem with the existing library, and this is not specific to Sangria, this is actually pretty common in other languages as well. That is that when you want to expose a GraphQL API, you need to define your schema kind of with a lot of boilerplate. Like you need to say, this is my root query type, and these are the fields that I have, and this field returns this type, and this type has these fields, and so on. And I had hundreds of case classes and seal traits and so on, ADTs in my REST endpoints, and I found that was a lot of boilerplate if I had to redefine everything. There are some macros in Sangria that can help you for some cases, but they don't support every type of every kind of type. So it's not that useful. So yeah, one of my first motivation was to cut down the boilerplate so that I would be able to turn my existing REST API into GraphQL quickly. Another thing that I wanted was to have a purely functional API. So I wanted everything to be typed. I didn't want to have some type any that you have to cast around. I wanted the errors to be explicitly returned and not have API that throw exceptions. I wanted the library to be user-friendly. That was also a strong motivation so that you could get started very easily. That's maybe because I'm a contributor to Zio, and that's kind of the philosophy of the Zio system, of the Zio ecosystem, to have to be very approachable, and so that you don't need to understand highly advanced concepts of functional programming in order to use it. And then the last thing I wanted was that I wanted to separate the schema, so the definition of all the types, from the resolver. What we call a resolver is for each field, how do we resolve that field? Which function do we need to call to get the response for that field? This is usually defined together. So when you build your schema, you say the resolver is that, the type is that, the name is that, and the resolver is that. But I wanted to be able to have a schema that we don't touch, and then you can pass one or another resolver depending on the situation. Okay, so I'm gonna show you an example of usage of how to create a small API with Caliban. So here, what you have here is a definition of a schema in the GraphQL schema definition language. So what does it mean? It means we have a type, which is just an object, pug, with 3 fields, a name, a list of nicknames, and a picture URL. So the brackets means that it's a list, and the exclamation mark means that the field is non-null. So you will always have a value for the name, for example. On the other hand, the picture URL, because there is no exclamation mark, it could return null. So it's a bit like an option in Scala. And the root query type that defines a list of queries that are available. So you have pugs that returns a list of pug. And then you have pug that takes an argument name, which is not optional, and returns maybe a pug. So this is the API that we want to expose. So how do we do that? So with Caliban, you actually define your schema using regular Scala case classes, and that's it. There is no special API or to define your schema. You just use case classes. So we only need to turn our GraphQL type into a Scala type. So the translation is pretty seamless here. I use an option for the picture URL, and that's it. For the query, it is also similar. The only difference here is there was an argument in the field pug, a name. So to handle an argument, we make our case class parameter take a function instead of just a value, a function from the case class to the result type. Why did I use a case class here, pug args, and why not a function from string to option of pug? It's just to give a name to that argument, because if it was a function from just string to option of pug, there would be no name to that that string. But by wrapping it into a case class, you can give it a name. I think it works if you don't wrap it in a case class, but the name will be picked automatically. I think it will be value or something. Okay, so that's how you define your query schema. What if you're to gather the list of pugs, you need to return an effect because you need to maybe gather the data from a database or stuff like that? Well, it's just the same. You can wrap your result in a task. Here it's task from Zio, but it could be a Bonix task. It could be a future. It could be a Cat's.io. It could be whatever. This is all supported. Okay, so now the resolver. So we define our schema. That was very simple. We just created some case classes. Now the resolver. Well, the resolver is just a value of that case class, because that case class contains basically some functions. By creating a value of that case class, you give the implementation of each function. So here, let's say we have a pug service that we can query to get the data we are interested in. So I just create a query value, and I pass a function that will gather the data. So for example, for find pug, query was expecting a function, so I provide the function from args and calling my pug service with the name from the args. So this is actually a resolver. So how do we turn that into a GraphQL API? That's where finally we'll start using Caliban. So first we create a root resolver. So this type is from Caliban. This root resolver takes possibly 3 things: a query root type, a mutation root type, and a subscription root type. They are not all mandatory. You can have only queries and no mutation and no subscription. So you just wrap your own type into the Caliban root type. And then you call the function GraphQL on that resolver. And this function GraphQL from Caliban will analyze all the types that are in your root resolver. So query, pug, everything that's included, and see if it knows how to handle that type. If it knows how to handle that type, then it compiles, all good. You have an API, and then you can just serve it. I will show you a bit later. However, if there is a type that Caliban doesn't know how to handle, there is a little more work to do. So Caliban knows how to handle a bunch of types. So obviously all the basic types from the Scala library are supported. So int, strings, booleans, list, options, tuples, of course. It supports functions, as I showed before. That's how we support arguments, GraphQL arguments. It supports future, zero. This stream is used for subscription. How about your own types? Like you must have probably your own business case classes and so on. So those are derived automatically at compile time using a library called Magnolia. So what that means is that any case class from your code, if it's using types that Caliban knows how to handle, it's going to be able to know how to handle that case class. That works also if your case class uses some other of your case class, like it can recursively know how to handle that type. What if there is some type which is not a case class and not a seal trait and not listed here? Then you have to provide, you have to basically tell Caliban how to handle that type, how to turn that unknown type into a GraphQL valid type. So you do that by providing your instance of the schema trait. So I have a little example here. Let's say we turn the picture URL. Instead of a string, it's a java.net.url. So that's not a case class, and it's not already supported by Caliban. So we need to provide a schema for java.net.url. So there are two ways to do that. You can just do new schema of java.net.url, and you have two methods to implement. One of them is to turn the java.net.url into a GraphQL type. So what is the name, what is the description of that type, what are the fields, and so on. And then the second method you have to implement is how to resolve that type. Like if you receive a java.net.url, how do you turn that into a GraphQL response type? So that's one way. Another simpler way is that if your type is a bit similar to an existing type, you can reuse the schema for this existing type to create your new schema. So for example, for the URL, we are gonna receive the URL as a string, and if we return the URL, we're just gonna return a string, right? So you can reuse the string schema, which is provided by Caliban, and then use contra map and provide a function from your type to the type that you reuse, here string, and that's it. So here, if you know how to convert a URL to a string, then you can just reuse the schema for string to make a schema for URL, and that's it. Okay, so there are a lot of examples you can see in the Caliban code how I created the schema for all the types that are already supported. So it's pretty simple to create your own schema if you need to. Okay, so that's how you handle unknown types. If all the types are known, then the previous code compiles. You call GraphQL and you have a GraphQL API object. What can you do with this API object? First, you can render it. So by calling api.render, you can see the schema definition in the GraphQL language. So you can compare with the one that you wanted and make sure that it's all right. But especially the most important thing is you can execute queries. So to do that, the first thing you need to do is to transform your API into an interpreter. This will perform additional checks that cannot be done at compile time. So it will verify that, for example, you don't have two case classes with the same name in different packages, and that would clash because in GraphQL each type name should be unique. You cannot have two types with the same name. So it will, if we do some additional checks like that, and then give you an interpreter. And the interpreter can then be used by calling execute. and passing a GraphQL query. And it will return an error or a result. So that's super simple. Typically, you will not call execute yourself. You just want to expose your GraphQL API by HTTP using a HTTP library. So Caliban comes with a number of adapters that take care of exposing the execute method using the GraphQL commonly adopted format. So it's basically a post request with a query operation name and a list of variables. So it takes care of that for you and just exposes an easy to use method to do that work. So there are adapters for HTTP4S, AKHTTP, Finch, and the newest kid on the block, UZHTTP, which is a minimal Zio-based HTTP server library. There's an example here for HTTP4S. So you just call make HTTP service, you pass an interpreter, and it gives you an HTTP route. And then you can serve that route with HTTP4S on the port that you want, and you can add middleware around it, and so on. There is also a make WebSocket service that returns a different route for if you have subscriptions. Okay, so yeah, I mentioned before, so Caliban is using Zio internally, but there are additional modules if you prefer using Cats, IO, or Monix that add the support. So you just need to add one import, and it will add the support for those effect types. It also supports Circe and PlayJSON. So if you use you can have a JSON directly in your API, and it will know how to handle it if it's Circe or PlayJSON. Okay, so now let me talk about a few more advanced features. One is called zQuery. The other one is called wrappers. So let's start with zQuery. There is a common problem that happens, especially with GraphQL APIs. That is that you could end up doing a lot of requests to your backend when there is a query. So here's an example. This is a GraphQL query. You request an order with an ID. You want to return the names, and you want to the name, and you want to return the list of products. And for each product, you want to return the name. So typically, a way to implement that using Zio here would be that you first do a get order request to get the order information from your database. And then for each product ID that you had in your order, you would get the product from its ID. And then you bundle that into something that you return. The problem with that is that you will end up doing one request for the order and then n requests for the product, n being the number of products in the order. And with GraphQL, because you can have a deeply nested schema, you can have an object in an object in an object, you can end up doing an exponential amount of requests to your backends if you have a lot of cases like that are nested together. And you could also end up doing multiple requests for the same thing. If in one part of your graph you're asking for something, and in another part of your graph you're asking for the same thing, it will request it multiple times. So how can we deal with that? So in Caliban, we introduced a type called zQuery, which is quite similar to Zio. It has the same type parameters, but it will behave differently. So I'm just going to change the code here. I just replaced Zio by zQuery. And instead of n+1 requests, this will actually execute 2 requests. How is it possible? In order to create your zQuery, you actually need to provide a data source. And with that data source, you have to define a function that, optionally, you can define a function that defines how to query multiple requests at the same time. And what zQuery will do is that before executing, it will look at all the nested zQuery inside all the Z-query that don't depend on each other. It will group them so that first you won't request the same one multiple times, so it deduplicates the requests. And then it will run the function from your data source to group them together if you provided that function, instead of executing them one by one. I have a small example here. Just the important part is that you see the run function that takes a list of requests, a list of get product requests, and returns a map containing the result for each of the product. So that's basically what you have to implement, and then you can switch your ZO type with a ZQuery type, and it's gonna run with those optimization. So this data type was actually implemented by Adam Fraser, who is on the call. Hi, and so if you have questions, maybe you might chime in. This is actually not specific to GraphQL and to Caliban, so it fits pretty well with GraphQL, but you might be able to use it in other use cases if you have the n+1 problem, basically. So at some point, it's going to maybe be extracted into its own library, so that everybody could use it in their own project. Okay, so that's how we handle query optimizations. Another thing that Caliban offers is a feature called wrappers, and what it is for is for customizing how your API behaves in a very flexible way. So with a wrapper, you can wrap some parts of the computation of a GraphQL query. So you can wrap the parsing, you can wrap the validation, you can wrap the execution of the whole of the query, you can wrap each field execution or the whole thing. And by wrapping, I mean that you can modify the input data, you can modify the output data, you can do something before, do something after. It's quite flexible. A few examples of the things you can do. So there is this operator that you can use to add a wrapper on an API. There's also a function with wrappers, well, with wrapper if you don't like the operator. So here I added on my GraphQL API max depth that will limit the depth of the fields that you can query. So this is I think a validation wrapper. So after the query is parsed, it will check the depth of the query, and if the depth is over the number that you specified, it will reject the query. It will fail. It will not execute it. That can be nice to protect your system against malicious queries. So there is a similar one, max fields. You can limit the number of fields that are requested. There is a timeout, so you can add a timeout on the whole query processing, or you can even add a timeout on just the execution, for example, or even some field executions. You can use it to print slow queries. So again, that's a wrapper around the whole thing. It will measure the time that it takes and print something if the processing is too slow. So those are examples of wrappers that are built in, but you can make your own. I implemented a number of extensions like tracing, Apollo caching, persisted queries. Those are extensions from the Apollo JavaScript library, which is quite heavily used. So I was able to implement those plugins just using wrappers pretty easily, just a few lines of code. So this is a very flexible way to add something to your API. Like if you want to report metrics to your own system, you can do that. Okay, there are more features that I will not talk about today, but I'll just briefly mention them. You don't have to have an API with all of your fields, because you might have a lot of them and you're going to have a gigantic case class, and this is limited to 22 fields. So you can have smaller case classes, and then you combine API together. There are annotations, so you can customize some parts. Like if you don't want to use the name of your case class, but you want to use another name for your GraphQL type, you can use it. You can use an annotation for that. You can add a description with an annotation. You can deprecate some fields with annotations. Caliban supports introspection, so tools will be able to introspect your schema and generate the documentation for you. There is a code generation tool. So if you don't have a Scala code yet, Caliban is very convenient if you already have your Scala code and you want to expose it, because you can reuse your existing types. But if you start a new project and you just have a GraphQL schema in the GraphQL language and no Scala code, you can use that code generation tool to create the case classes from the GraphQL types. That's a nice bootstrap tool. And more features we are adding. We are still adding some features quite often. But the last one I'm gonna talk about for this talk is something that was added at the beginning of this year, which is Caliban client. So there wasn't any GraphQL client library in Scala actually. There was just something that give you some helper to copy paste your GraphQL query string and run it, and then get JSON back, and that was it. There was nothing more. So I decided to create another module of Caliban using the same principles as the server library, which are limited amount of boilerplate. I wanted to be able to use a client very quickly on any given schema, and then to be strongly typed. So I wanted to avoid what most client developers who work with GraphQL have to do and usually do, which is they create their queries in their tools and then they copy paste the queries to their code just as strings, and then you just use that. But if the schema changes and you need to change all your queries, you just have to go through all of them because they're just strings. The compiler will not help you. So I wanted something different. I wanted to have queries that are typed, so that if the server changes, you can regenerate the schema and you would find immediately if something breaks. And then since I wanted to use Scala for creating queries, some concepts of GraphQL, such as aliases or fragments, became unnecessary because the library will take care of it for you. So if you, for example, with GraphQL, if you request multiple fields, the same field multiple times, for example, with different arguments, you need to use aliases so that they don't have the same name in the response. So that's something you don't need to care about. Here it's done for you. So I will show you a quick example on how to use Caliban client in 3 steps. So the first step is the code generation step. You have a GraphQL schema and you run a tool and it will generate some helpers for you. You technically don't have to use the code generation tool. You could write the helpers yourself, but that's possible, but that would be more boilerplate actually. The tool is an SBT plugin, but it's also exposed as a simple library, so you can use it with something else than SBT or your own code, possibly. So you give to that tool the path to your schema, so the GraphQL schema. You can also give a URL now, the URL to a live GraphQL API, and it will get the schema by introspection. That's also supported. And then you run that tool. And it's going to generate, as I say, a bunch of helpers. So for example, if you had that GraphQL type location, which has 2 fields, latitude and longitude, that return a float, that would generate this Scala code. So it would create a type location with an object. And in that object location, 2 functions, 1 for each field. And this function return a selection builder from a location to a double. So that means that you are working on the location object and you want to extract a field that returns a double. Okay, so that's for the code generation. Now that you have your helpers generated, you can write queries. So writing queries is just combining selection builders together. You can only combine selection builder that are on the same type. So I can combine here two selection builders on location, but I cannot combine a location with something else. It would not make sense. So here I combine my two selection builders on location, and it gives me another selection builder that returns a tuple of the result of the two fields that I combined. Of course, you can map a selection builder to a case class. There is a map function and map n function, so you don't need to carry those big tuples around. You can just map it to a case class. So the way it would work typically is that if you want to write a query, you would first find what is the root query type, because you have to start from the top. Very usually it's named query, mutation, or subscription. So you would type query dot, and then you would your IDE would show you all the helpers in the query object. So let's say you pick search, it will require an argument, which is a station name in this example. So you put the station name, and then it will ask you for a selection builder of searchable. Okay, you type searchable dot, it will show you all the fields available on searchable. You pick stations, and then it's going to ask you a selection builder of station, and so on. Station.name doesn't require anything. Then you add a station.location. It requires a selection builder of location, and you can use the one that we created just before. Because the selection builder is just a simple Scala value, you can reuse one in multiple places. So here I used location, and if somewhere else in my query I was needing a location, I could reuse it as well. So you can understand that that's why you don't need GraphQL fragments. GraphQL fragments are there because GraphQL is not powerful enough to have values that you can use here and there. Here you don't need that. You can just reuse the Scala value multiple places. So this is how you write a query. So it reads in a way which is not so far from the GraphQL language, actually. It feels pretty similar. And then how do you run that query? So Caliban client depends on a library called STTP, which is a HTTP client library in Scala. STTP is really flexible. It has a core library that is used to define requests and responses. And then you can use it with a lot of different backends. So you can use it with, like here, I used a async HTTP Zio backend, but there is a Future backend, there is a Monix backend, there are a lot of different backend, Akka HTTP backend. You can pick the one that you want. Caliban client only depend on the HTTP core, then you can use what you want. So from the query that we created in the previous slide, you just need to call two requests and pass a URL. And this will turn it into a HTTP request object. And then you can use send to execute the query. And what's important to realize is that as a response, you don't get a JSON-like type. You get the type that is exactly what you had in your selection builder. So here we had a selection builder of list of string and a tuple of double, and that's what you get from executing the query. So Caliban client takes care of creating the GraphQL query from your selection builder, but it also takes care of parsing the response back into the type that you expected. So everything is strongly typed. That's the point. So yeah, Caliban client is available for Scala.js as well as Scala. All right. A few closing. Yep.
Could I ask a question, or do you want?
Maybe I almost finished. So give me 2 minutes, and then I'll take questions. So yeah, just a few mention of the things on my backlog, the thing I'm working on or I would like to work on in the future. I would like to generate a GraphQL API from Tapir. So Tapir is a library for defining HTTP endpoints, and then auto-generating documentation and so on. So it's really good if you use REST. But I'm working on a experimental module to turn a REST API into GraphQL instantly. Basically, it would take all the REST endpoint and put them in a GraphQL schema. So I have a proof of concept that's pretty cool. I'd like to have an adapter for the Play framework. I've never used Play myself, so if there is anyone among you who want to become a contributor, help would be welcome. There is not much work to do because Play JSON is already supported, so it's just about exposing the endpoint. The Caliban client doesn't support subscriptions yet because they use a WebSocket protocol that's a bit more complicated. I would like to add that. And at some point, I'd like to look into supporting Scala free. All right, so everything I talked about here is covered in more detail in the documentation. I encourage you to look at the resources page that has a link to blog posts that I mentioned before with detailed examples of zQuery, of wrappers, of Caliban client as well. There is an examples folder that has a lot of examples as well. So you can see for all the adapters and so on. You can, if you have questions, you can come to the Zio Discord. There is a Caliban channel where I'm pretty often, and there are some other contributors who can help. And you can find me on Twitter as well. All right, that's it for me. Now I will take any questions if you have. Let me open the Slack.
Feel free to ask questions on Slack as well. I've got it open and I can read it out.
I got a couple questions about 5 slides back.
Yeah. Okay. 1, 2, 3, 4, 5. Is it this one or?
Okay. One. Click one forward. Okay. Yeah. This where you have the selection builder in the query, in the client query. Yeah. Okay. That's
all
right.
Right.
So, so can you explain what the innermost thing is there? Like, what is location in this context here?
So location is what I created just above, like here.
Yeah.
Which is I combine the selection builder on two different selection builders. One is latitude, one is longitude. So I combine them into one selection builder. So that basically means that I want those two fields.
I see. So the station.name combined with station.location. Oh, I see. Because you're saying a single selection builder can only be on one type.
Yeah, I can combine types. I can combine selection builders that are on the same type, right? So let's say on station, I have a lot of available fields. So I have a field name that returns a string. Then I have a field location that returns a location. But location is an object, so I need to define what fields I want in location.
Right. So you're saying that in this particular example, you just defined that val, but you didn't have to. You could have just said location.latitude.
Exactly. Yeah. I could have it done inline. I just wanted to use to reuse one just to show that these are just simple values, and you can.
Right.
If you need to repeat some section, you can just use a value like that. Otherwise, you can just do it inline, of course.
Got it. And then the searchable is a case object or something that you auto-generate from the schema, or what is it?
Yes. Yeah. It's a bit. If I go back, it's like location here. So location.latitude. So latitude is just a function on the object location. So searchable it's also an object, and there is a def stations in there.
Okay, got it. And then on the next slide, so I'm assuming all the way till the map, this is lazy. is absolve lazy, or is?
Oh, so here actually you have a task. With just
okay,
this
got it.
code,
Okay.
it's not running. It's not running it actually.
Yeah.
You have to run it at some point. Yeah.
Right. Okay, and that's what you tie into your HTTP client then.
Yeah, the absolve here is just because I think HTTP returns an either error or response, and absolve move the either into a zero type. So instead of being an IO of either, it moves the error to the error channel of zero, and then you just get the value that you want. You don't have the either floating around.
Right. In case I don't get a chance to say it afterwards, thank you for writing the first GraphQL client library. It's totally awesome, dude. Thanks for doing it.
Yeah, I think that's pretty nice. I was the only equivalent that I found is in Elm. So I found that there's a library that have a similar approach that is pretty cool. But yeah, I think I was able to generate a client for a complex GraphQL schema like GitHub. They have a gigantic schema, and you just run the tool, and then you have everything. You can just start querying very quickly.
Right, so presumably the server and the client in this case will share all the case classes.
You can. Well, initially I thought about reusing the server for implementing the client, but I ended up not having any dependency between them, because usually the client only wants a subset of what the server has to offer. So it ended up being different case classes, even though for the basic types, like if you have, I don't know, a user ID, you can reuse it, of course, between both of them. But the bigger types usually are not the same, because the client only wants a subset. But you can share types between, of course, you can map, for example, when you have a selection builder here, you can map it to a type, which is the one that you had on the server side as well. There's no problem with that.
Right. Like for, yeah. And in the case of Scala, yes, most of the, if all the types were shared, then the DCE would just remove most of the junk from the final JavaScript file anyway. So I guess you're thinking more likely scenario is that the client implementer is going to write a smaller subset of case classes that, or is going to use a smaller subset of case classes than what's defined on the server. I guess that's what you're. I find it that's the latter, the opposite is more common, where people don't want to mess with it; they just want the whole thing, and that's it.
Yeah. Well, you lose some benefits of if you get the whole thing, you lose some of the benefits that you can ask only what you want. But yeah, in some cases you want everything.
No, I guess maybe I guess that proves that I'm misunderstanding. So I mean, I think the point of Caliban on the server side is that, correct me if I'm wrong, is that you define your entire schema in case classes, such that it could be compiled down to the GraphQL IDL and distributed, but also that you could then have your server-side code be using the same case classes that were used to generate the IDL, right? So that you're not duplicating the types in any way, right?
Oh, so you mean like here to generate the client?
Right. To generate the client, right? You're going to get all the case classes.
Oh no.
In the client are going to be from the original schema file, right? The question is that schema.
So the schema path here is a GraphQL schema. It's not the Scala one. It's the in the GraphQL language, or a URL which returns GraphQL.
Right.
So yeah, it's not gonna reuse the server case classes, because actually it's not creating case classes here. It's just creating some helper functions.
I see.
Yeah. So it's up to you then to map it to your own case classes.
Ah, got it. Okay. So you provide the machinery to do it,
yeah,
but not necessarily you're not kind of automating that. Got it.
Yeah, each field returns its own type, and then if you combine fields, you get tuples that you have to map to case classes if you want. Because as I said, quite often it's not going to be the same case classes as the server. It might be, but it will probably be smaller case classes. Or also on the server side, your case classes might have arguments, so they might be functions that on the client you don't want the arguments.
Fair.
Just want the result. Yeah.
Thank you.
Okay, so if it's okay, if there's any more questions, if we could move it to Slack, that'd be great because we're running a little bit behind schedule. Thank you, Pierre, for a fantastic talk. Really appreciate it. Really appreciate it. I would say big round of applause for Pierre, but I don't know if you'll hear it. There's always Slack, yeah? Yeah, there you go. From me anyway, yeah? You hear mine, yeah? Great.
Yep.
Before introducing the next speaker, just a quick announcement, just so I don't forget. SF Haskell Meetup, who share the same kind of group of people who are interested in functional programming, have got a meetup on April 30th, and it's also on Zoom and online if anyone's interested in attending. I'll post it in the Slack channel for those interested. Without further delay, if I can introduce our next speaker, Bill Vinners. Bill, as everyone knows, he's the co-author of the book Programming in Scala with Martin Ordesky. He's had that is probably the most popular book most of us learned Scala from. So it's like a great privilege to be able to have him at this meetup. I'm really super happy that he was happy to do this to the talk tonight. So big round of applause for Bill.
Hello, can you hear me? I actually didn't test these headphones. You can hear me okay?
I can hear you, yeah.
Anyway, should we do a 5-minute break for people or are they gonna hold it during my whole talk? I don't know if you do that on Zoom meetings or.
We didn't we didn't last time.
Okay, well I'll just head out. You guys can take a quick break.
Unless I get 20 people saying let's have a 5-minute break on Slack, let's carry on, I say, yeah?
Okay, so what I have prepared, I can just give you a little background in case people want to take a quick bathroom break. I was going to give a talk on the type system at Scala Days, and I was going to practice it at Northeast Scala, and of course all these got canceled, so I did it online at Northeast Scala, and then I gave it again a little bit slightly different at Scala Love last week, I think it was. So this one, I have a little more time, so I added a few slides. So I cover most of the type system except for higher kinded types tonight. And what I did is I have a little Q&A slide I usually have at the end that I just stuck in like several places. So what I'll do is I'll go for a little while, and then before I change subjects, I'll just say, if anybody have questions, we can talk about like that subject. That's what I was thinking I'd do. Make it a little more conversational, but a little more structured. So let me just share my screen here. The talks about is just Scala's type system. I can't, there we go. Okay, there we go. And so I'm gonna actually start also with this slide, which I usually put at the end, just to let you know what Artima does. That's my company. We do consulting and training for Scala, and we actually do have positions for US people. If anybody's looking for a job right now, feel free to contact me. We are even more available now as of a couple of months ago when people started pulling back. So if you need any help, think about us. And the other thing I am is I'm one of the community representatives on the Scala Center Advisory Board. So I am supposed to represent y'all to the Scala Center, but I sometimes don't get a lot of complaints or concerns expressed to me. So what I started doing is these little for free listing brown bag lunches. If your company has brown bag lunches, and you want me to come and just join remotely like this, and ask you questions about Scala, like what you like, what you don't like, what that kind of stuff, what your concerns are, then that would really help me. I could bring that back to the Scala Center. So that's a freebie I do. Anyway, so with no further ado, hopefully everybody got back from their break. So this is about types. So like the basic, most simplest type I can think of is a class. When we define a basic class, we create a type. So when I say trait fruit, and a trait, I'm considering a kind of class, a special kind of class that you can multiply inherit from. When I create trait fruit, I get type fruit. fruit. And when I create trait plum, I get type plum. And then at the heart of Scala's type system is subtyping. So when I say trait plum extends fruit, that defines plum as a subtype of fruit and fruit as a supertype of plum. So the way we draw that in a UML diagram over to the left is we draw an arrow from the subtype to the supertype. So what the little simple hierarchy I created here is there's two kinds of fruit, plum and apricot. And then there's a pluot below plum and apricot. And pluot is a real thing. It's a hybrid that, someone crossed a plum and an apricot, and they got something that has both plum DNA and apricot DNA, sort of a Frankenstein fruit called pluot. So in Scala, I can't actually see it because my gallery is over here. How can I move that? Oh, gallery. No. Anyway, I will imagine what I wrote over there. Trait pluot extends plum with apricot. That means pluot has two supertypes, plum and apricot. Right, so that's how we draw that, and everybody's familiar with that. And that's sort of like the simplest types you can create in Scala. And so when I, my kind of path to Scala was I did C programming, I guess. I did some things before that, but I did a lot of C programming in industry. That was sort of the first thing I used at a job after college. Then C++. And C++ is when I first encountered an object-oriented programming, and that's when I learned about subclass, superclass, base class. What do we call it? Base class, and I forget what we called it. But anyway, they had diagrams too with arrows going between types, but the arrows pointed down, like from supertype to subtype in C++. And when I switched to Java, the arrow went the other way. It went up from subtype to supertype. And I thought, wow, this is so different. But I really had no idea why it would matter which direction the arrow went. But when I came to Scala, I actually had an insight, because if you turn it to the side like this and say plum is a subtype of fruit, that looks a little bit like a function type, right? This function goes from plum to fruit. And it turns out you get that for free. You get that implicit conversion of that type. So for example, this is a method that takes a plum and returns a fruit, right? If I have a method that takes a fruit and I have a plum in my hand, one way I could pass my plum into the eat method is to convert it explicitly from plum to fruit, right? And then now I have a fruit and I can pass that right in. Well, I don't have to, because I get that conversion implicitly, right? It's an implicit conversion from plum to fruit. That's what the arrow in the diagram, I think, it's a good way to sort of a good intuition for that arrow. And the other thing I think I've observed that it means is that you don't have to change memory. So like the fruit, when I create a new fruit, I get an image on the heap for that fruit. If I create a new plum, I get an image on the heap that may be a little bit bigger. Plum may extend the fruit image. That's what extends means. But it includes the fruit image. So to look at this as a fruit, I don't have to change memory. I can just say the pointer is now type fruit, and its fruitness was there in the same spot as if it was just a plain old fruit. So that's one thing about this is a subtype of implicit conversion, is you'd never have to change memory, which is not true of general implicit conversions. And then the other thing is it's reflexive and transitive. So what reflexive means is that a type is a subtype of itself, and dually a type is a supertype of itself. So fruit is the subtype of fruit. That's how it's defined. If you can kind of think of it as I get this implicit conversion from fruit to fruit, or apricot to apricot, which you don't really have to call because you're already an apricot. But if you look in the diagram, the UML diagram, that's actually what's really the truth, is that there's 4 more arrows there. And there's always an arrow from a type to itself in the UML diagram. We just never draw those because they clutter up the diagram. And then transitive means that given that pluot is a subtype of plum, for example, and plum is a subtype of fruit, that means that pluot is a subtype of fruit. That's what transitive means. So that little curved arrow I drew in the middle is also true. You usually don't draw that in UML diagrams, but those are all there also. So that's transitive. So I thought I'd just pause this. So there's my talk. No, that's just the first Q&A slide. I thought I'd just pause and see if anybody has something to discuss. And I forgot to start Slack up. But, anybody have a question on? You can put it on Slack or chat. Let me find the chat. Where is chat? Oh, oh, here it is, chat. Chat would be here. Okay. Nope, nothing in chat. And where would they put questions in the Slack group? Salar, maybe random or the lobby?
SF Scala, I think, is the channel.
SF Scala. Oh, okay. It seems like it's empty for me. I have to join the channel. That's my problem. Let me do that. Okay. Yeah, let's use Slack instead. So you're an apricot. Okay, that's good. All right. Well, I can move on if nobody has a. That's not a question. That's a statement, and it's probably a true statement. Or you can actually unmute too.
I just had a question, or
Sure.
like rather an observation. If you go back to a slide where you had the reflexive
Yeah,
annotations.
They're very humorous. The diagram with the little arrows like this. Yeah. Yes.
The next one where you had the arrow from pluot to fruit.
Yes.
So doesn't this? So I've seen like enough category theory diagrams right now to say that, you know, this almost looks like, you know, each of this type actually represents a category with the reflexive type actually being the ID, and then the arrows just being the functions or the arrow types.
Yes, it is. It is a category.
Okay.
Scala's type system is a category. I'll talk about that in a few more slides down, but that's a good.
Gotcha.
I mean, because it's category, you have to have an identity arrow. Basically, it's objects and arrows. And here, let's not call it object. Let's call it dots and arrows.
Right.
Thingies and arrows. So the thingies are types, and the arrows, they have to be identity, and that's true for everyone. And then you have to be able to compose, right? If this one composes with that one, then you get that. And that's it, really, for a category, I think. So sure enough, it is a category. Scala's type system. The subtyping relation forms a category.
Gotcha. Thank you.
Okay, so let's we can go a little farther then. If there's nobody else other than someone declaring they're not a fruit. Okay, that's good. So then the other thing that I think is pretty handy is to think of types as sets. So kind of like that they represent sets of values, which we call inhabitants of the type. So a couple examples I've drawn here. One is, first of all, this is kind of like visualizing a set. The one in the upper left corner is called labeled unit. That's the set unit. And it has one value, which is the unit value, which we write as empty parens or empty curly braces. Can't really do with my fingers. Or Boolean is an example. It's a type, Boolean, that has two inhabitants, true and false. Well, the set that corresponds to that, you know, that I've labeled Boolean has two values in it. The elements of this set are values, instances of type Boolean, and it's just two of them, true or false, right? Traffic light over here, I create a sealed trait traffic light, and I made object red, yellow, and green that extend traffic light. So there's only three possible there's only three possible instances of traffic light because it's sealed. So this type has three inhabitants, or the set that sort of it corresponds to has three elements, which are values, red, yellow, blue, green. Or int has 2 to the 32 inhabitants because it's, you know, int.min value to int.max value. And there's 2 to the 32 of those. They couldn't all fit on this diagram, but you can kind of get the idea. That's a finite number of elements in the set that corresponds to int, right? So that's, I think, I use that throughout this sort of metaphor throughout the whole talk. So when you look at them as sets of values, then this inheritance becomes, you can really diagram it with a Venn diagram. So when a Venn diagram is just a graphical way to draw sets. So what I have is this big yellow circle, which is my fruit set. And inside I have some dark purple ones on the left, which are plums. There's a sort of orange circle, which is the plum. Oh, I've actually got my colors wrong, I just noticed. Plum's supposed to be dark purple. But anyway, the orange one, this guy on the left here, if I can circle it with I'll have to use words. Can't circle it with my mouse. The plum and the apricot circle has apricots in it. Pluots belong both to plum and apricot. So that's kind of like an intersection of the sets. Fruit is the union of all those sets. So that's basically is a subtype of, that relationship corresponds to is a subset of, when you sort of look at it as sets. And the elements of these sets are values, possible values. And usually it's an infinite number of elements. But things like unit and Boolean, they're finite, or even int. But when I said trait fruit, actually that was an infinite number of potential elements because it wasn't sealed. So anyway, so that's one way to correspond. And then another thing is what widening means. I think an insight for widening a type, which is what Martin Odersky said he wanted to call when we get that implicit conversion from a subtype to a supertype, that's widening the type. And the intuition I have for that is if you look at the plum, if I have a plum in my hand, I want to pass it to a function that expects a fruit. It's going to convert plum to fruit. That's an implicit conversion I get. If you look at the circle around plums, it's kind of smaller, and the circle around fruit is bigger. But every plum is a fruit. So every element of plum is an element of fruit, because plum is a subset of fruit. But the fence, if you think of it as like a fence around the inhabitants, then the fruit fence is wider than the plum fence. So that's how you're widening the type. So this little arrow I drew going between the plum fence and the fruit fence is I'm widening that fence. So anyway, that's an insight, I think, an intuition for widening. And now let's put any and nothing on there. So any is the top type in Scala's type system. And that one represents the set of all possible values. So that's the set of everything or anything. Every single possible instance of any class in any type in Scala is included in any, right? Whereas nothing is like an empty set that has no inhabitants at all. So it turns out, if you go look it up on Wikipedia, that an empty set is a subset of any other set. And correspondingly, nothing is a subtype of any other type, right? So that's you can kind of see the correspondence between the subtyping and sets is T being a subtype of any means that T, the values, the elements of type T's set are by definition a subset of any, because the set of any has everything. So of course it's going to have every T instance. Whereas nothing's an empty set. It just, no matter what T is, it's going to be a subset of, because that's how it's defined in set theory. So that's any and nothing, the top and bottom types. And then lastly, before our next Q&A point, what I wanted to do is say another way to think about these is to count the inhabitants. So I made them all contrived to be finite. So nothing has 0 inhabitants, has no elements in that set. Pluot, where's the Pluot? Pluot over here, you can kind of see it looks like a boat. That's got 3 inhabitants. Plum has 1, 2, 3, 4, 5 plus 3, so it has 8, because the pluots are also plums. Apricot has 4 and 3, that's 7, because the pluots are also apricots. Durian, I can't see, it's behind there, so it has some number of like maybe 6-ish. Looks like chocolate chips over there, but they don't smell like chocolate. And then fruit is like, plums plus pluots plus apricots plus durians, all those guys together. Unit, I just stuck it up there as an example. It only has 1 inhabitant. And any has everything. So if I just replace over here on the left-hand diagram, I place with the counts I just did, right? I just put the number of inhabitants in there. What you'll notice is that anytime a type is a subtype of another type, its count of inhabitants is less than or equal to the count of inhabitants of the super type. So pluot is a subtype of plum, and 3 is less than or equal to 8, right? So that's another way, if you're counting, if you're doing inhabitant counting, the subtype is a subtype of relationship maps to is less than or equal to for the integer counts. Okay, so that's another good stopping point. Anybody have I'll switch over to Slack, see if there's any other question about that stuff so far. Traffic light is a 4th type. Yes, but it's abstract. Yeah, that's a good question. So let me go back to that. So traffic light is a 4th type. So there's 4 types. Okay, so that's this guy. There are 4 types here: traffic light, red, yellow, green. But this is not a set of types. This is a set of values, and there's only 3 values. Red is a value, yellow is a value, green is a value. Traffic light is a type, but it's not a value. And actually, red's not a value. Red.type is the value, which I'll talk about when I get to singleton types. Red.type, yellow.type, green.type are the 3 types there. So that's 1, and okay. All right, good.
So another question.
Sure.
If you go to the slide where you had the arrows for starting from unit, or sorry, nothing,
Yes.
and you talked about widening.
Right.
So I think before this slide, I forget which slide was it. You said that like from pluout you could go to apricot.
Yeah, it was right
Right?
before that. Yeah.
Yeah. Okay. So from plum, you're going to the upper type fruit.
Yep.
So okay. So but then when you go to the next slide, everything above pluout makes sense, but I do not understand how you could go from nothing to pluout.
Yeah, it's a little bit of a stretch for your brain, but you can think of the fence around nothing, because nothing has 0 inhabitants, right? As being infinitesimally small. It's just like a point, and it's sort of inside. It's defined to be inside every other set. And I actually had to look that up on Wikipedia to make sure that was true, and it was. It's defined that way, that the empty set is a subset of any other set. So the only way you could think of it is there's like an infinitesimal point that's got like the fence around nothing. And so, if I widen that to plum, I'm widening that little infinitesimally small point to something bigger. I think it's a way to.
So that slide was talking about in terms of set, right? Okay, gotcha.
Mm-hmm. Yep.
Yeah. Okay, in terms of set, then I agree. Okay, fine.
Yep. I mean, coming to Scala, I hadn't had a bottom type like this before, where there was like a type that's a subtype of everything. Like, actually with nothing, sometimes you'll see like little arrows down here, but just kind of imply it's a subtype of everything. But there's an arrow here, 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 and that sort of maps to set theory very nicely also. So, okay, infinite sets can be subtypes. Yes, correct. Yeah, my cardinality, I use a sub, like, I'm sorry, I can't see what's behind this. Let me move this, and I know how to do this. I have the technology. Now I can read your comments. Hey, there we go. I just drew my cardinality comment. Well, does infinity? I mean, there's different sizes of infinity, so I'm not quite sure how that works, but you can have like an infinity that's twice as big as the other infinity. And like the set of positive integers is infinite. The set of integers is also infinite, but it's a bigger infinity.
No, they're
right?
the same. They're the same because there's isomorphism from a set point of view. But I was more interested, yeah.
Okay.
But the real numbers have a different cardinality than the integers. But I was just curious about whether infinite sets could have a corresponding type in Scala and different ones.
Oh yeah, fruit. Like when I said trait fruit, that's an infinite set of possible inhabitants. The set has every possible inhabitant. So like string, it's an infinite set. So if positive integers and integers have the same number of inhabitants, excuse me, it still works. It's less than or equal. Of course, those aren't subtypes, but it's the going to the this guy, it's less than or equal to. So if two things are equal, it's still it's still going to work.
That works.
Yeah. I mean, we have an example right here. It's this one. Plum is infinite, fruit is infinite, but there's more fruits than plums because apricots aren't plums, and we can have apricots, right? So this is a bigger infinity than this one somehow, I think. But you're stretching my math. Anyway.
Yeah, that clears it. That's good.
Yeah. Okay. So we can go on a little farther, and we'll stop again. So so getting back to category, one of the things that Scala's type hierarchy is a preorder. A preorder is like a total order is like integers where every integer is less than every other integer. Like the equivalence class that has one thing in it, and so there's like for any two integers, there's a relationship less than or equal to. Let's say if you want to do it that way, because then you can have the same integer in the relationship, and it's when you switch it, it always is like true and false, right? It's consistent. So there's one total order across. A partial order, that you could be like a few things that aren't, for which that's not true, like a float that's primitive type in Java, because of 0 and -0 being in the same equivalence class and not a number, not sorting correctly. That's a partial order. And then a pre-order is there can be things that don't have a relationship, like plum and apricot actually don't have a subtype or supertype relationship at all. So that's a pre-order, and a pre-order defines a category. So anytime you have a pre-order, you have a category in category theory. And then another thing this is very close to in Scala 2 is a lattice. And a lattice, it actually isn't a lattice in Scala 2, but it is a lattice in Scala 3. So I wanted to talk about like latticehood and what the problem was in Scala 2, and what one big change in Scala 3's type system that came out because of this to achieve a latticehood. What a lattice requires is that for any two types, there's a least upper bound, which they call a join, and there is a greater, like a unique least upper bound and a unique greatest lower bound. It's called a meet. So here, like, for example, plum and apricot, fruit could be its least upper bound. That's fine, it has one. And that's important in Scala because Scala has subtyping and type inference, right? So Java has subtyping, but it didn't have type inference, so it wasn't quite so important that it was a lattice. But what Scala has to do is it has to like compute least upper bounds a lot when it's inferring types. For example, the code on the bottom right-hand corner, I've got an if else where the then side is type plum and the else side is type apricot, but I didn't give a type myself. I didn't explicitly annotate f with a type. So the compiler is going to have to figure it out. And what it does is it looks at the if side and the then side sort of and the else side, and it finds the nearest supertype that both of these are a subtype of. In this case, it's going to find fruit, and the type of f is fruit. So that's all fine and good, except when you throw in type parameters. So when you see like square brackets on a type, that's called a parameterized type. So t there is a type parameter, and show of t is a parameterized type. That's what that's called. And so what I'm going to do is, like by making that, when I make trait fruit, I got one type, right? And I trait plum, I got one type, plum. But when I say trait show of t, that itself, just one trait, generates an infinite number of types. So what I get is show of any, show of fruit, show of plum, show of apricot, show of fluid, show of nothing. But I also get show of any, show of fruit, show of plum, da 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 da. And then after that, I get 3 shows of all those, and then 4 shows of all those, all the way to infinity, right? An infinite number of shows of any, an infinite number of shows of fruit, which you never get to. And each one of those is a supertype of nothing and a subtype of any. But they're not related to each other because show, the type T in show is invariant. So that's like Scala has declaration site variance. So if you put a plus sign there, it's going to be covariant. If you put a minus sign, it's contravariant. But this one's invariant, and so these guys are just kind of all siblings. But there's an infinite number of them, and so far so good as far as lattice goes. The problem comes with covariance and contravariance because it gets more interesting. The plot thickens. If I make a trait basket of plus t, that means basket is a covariant in its type parameter t. Again, I get an infinite number of types. I get basket of fruit, basket of plum, well, basket of any, basket of fruit, basket of plum, basket of apricot, basket of fluid, basket of nothing. I get basket of any, basket of fruit, basket of plum, right, all the way to infinity. Except what's interesting about these guys is that because it's covariant, the relationship, like an inheritance relationship between the type parameters of 2 different parameterized types, 2 different baskets, implies an inheritance relationship between the parameterized type. So that's what covariance means. So for example, because plum is a subtype of fruit here in the left-hand side, a basket of plum is also a subtype of basket of fruit, kind of in the right over there to the right. The inheritance hierarchy kind of maps in the same directions as the type parameters, inheritance hierarchy. And a basket of any is an any. So you can see kind of basket of any goes down below any there. Then I did another one where it's basket of any. That's actually a basket of any because a basket of any is an any and it's covariant. So therefore a basket of any is a basket of any, right? Basket of fruit is a basket of any. You can kind of see each time I go down to those type parameters, it sort of maps that way. And that just goes on to infinity. getting smaller and smaller, and that's how covariance looks. Contravariance is even more interesting, color-wise, because contravariance is about what you can consume. So this is trait iterative t, and I got a minus sign, and that means that there is an inheritance relationship of parameterized types implied by an inheritance relationship of type parameters, but it's the opposite. So here, because plum is a subtype of fruit, an eater of plum is actually a supertype of eater of fruit. You can see the yellow ones down up below this time. And the reason is because it's about what it can eat, for example, what something can consume. If there's a method that says, I want you to pass me an eater of plums, what that method can do is feed plums to whatever you pass in there. Well, an eater of fruit can eat plums because a plum is a fruit. So it's actually okay to pass an eater of fruit where an eater of plum is asked for. And that means eater of fruit's a subtype of eater of plum. So it turns out that eater of nothing, if somebody wants an eater of nothing, that means I can't pass anything to it. Well, I can take any kind of eater at all, right? So you can even pass an eater of any. That's sort of the top type of this hierarchy. So an eater of nothing is any. So kind of what was blue is on top now, and what was green, eater of any, is the lowest one. But then if you put another eater in there, it flips it. An eater of any, which is like an eater of fruit would be like a shark, right? Something that eats fruit. But it flips. And so now you see greens on top again. And so this goes to infinity where it goes green, blue, green, blue, green, blue, green, blue, green, blue, all the way to infinity. And that's kind of hopefully can give you a little bit of an intuition about contravariance and how it's different from covariance and invariance. But anyway, back to lattice. Here's the problem, and this is in the Scala 2 spec. It actually has a little paragraph about this. It says, the least upper bound and greatest lower bound do not always exist, and in Scala 2. And the problem is that it's kind of a contrived example, but you can do it. I say trait basket of plus t, like I had before, 2 slides ago, and then I make 2 subtypes, fruit basket and int basket, and fruit basket extends basket of fruit basket. That's called f-bound polymorphism, by the way, when you use like a class that you're not finished defining yet as a type parameter for the super type. So an example of that is ordered. You know, if I say class person extends ordered of person, I'm putting like the class I'm actually in the process of defining using it in type parameter. That's called f-bound polymorphism. So I can do that. Fruit basket extends basket of fruit basket, int basket extends basket, int basket. And then if I go do this if val f equals, and on one side of the then side of my if else, I have type fruit basket, and the else side of I have int basket. I've got to find the least upper bound between int basket and fruit basket. Well, they're both baskets of something. They're both baskets of something. And then, so since it's covariant, I have to look for the least upper bound of that guy. Well, they're both baskets of any. There's a basket of fruit basket is a basket of any, and a basket of int basket's a basket of any. So you could think, well, maybe it's basket of any, right? Well, it turns out they're also baskets of any. But they're also baskets of any, and they're also baskets of basket any. And it turns out that the least upper bound is the farthest down one, the one that has an infinite number of baskets of any, which really doesn't exist, right? That's the least upper bound. So what the really early days Scala compiler would do in this case is explode because it would run out of memory. But what it does now, it just says, basket of any. But it's not really the least upper bound, right? So what they added in Scala 3 in Dotty is called a union type. And they added the do also an intersection type. The union type is just stuck it in between fruit and the sort of the plum apricot siblings. And it's plum or apricot, you use a little pipe there. That means it's the union of the inhabitants of the 2 types, plum and apricot. So if you look over here on the right-hand side, I've got 3 arrows kind of pointing to plum, pluot, apricot, all those sections. Plum or apricot is the union of those 2 sets. It happens to have the same number of inhabitants, right? Because fruit, there's only 2 kinds in this diagram. It has the same actual number of inhabitants as fruit, but it doesn't have to. And then the dual is called the intersection type. That's an ampersand. This is also in Scala 3, plum and apricot. And that's the intersection. So at the bottom, I just say plum, the upside down U is like intersect, apricot. It's the boat-shaped thing that's just pluots in this diagram. That's what's plum intercept apricot is. But it means that, like, if I were to go back here, in Scala 3, F would have type fruit basket or int basket. That's what its type would be inferred to. It's the union type. And that means it's got a lub. It's got a least upper bound. So that means in Scala 3, the type system really is a lattice. Okay, so I thought that'd be a good point to stop. Anybody have a question about that stuff?
Yeah, I do.
Sure, yeah, go ahead.
Is there a difference between Scala 2 and Scala 3 with respect to the relatively common and obscure usage of extending a trait with serializable and product so that it could infer properly for containers?
Yeah, that's a good question. This talk is too abstract. That's actually a practical one. So I don't know the answer. But was that Philip? I mean,
yeah, Phil.
I can't tell who was talking, but yeah.
Phil DeRome.
That's a good question. I kind of like to find out, and I'm not sure how to get the answer to you, but I'll try to find out about that because that's been a pain for a long time. The type inference of that. Yeah. Okay. I'll try to find out. Does anybody else have a question?
Yeah, I had a question.
Sure. Shoot. Yeah. Go ahead.
So if you go back to the slide where you had the any of the holes, we were trying to find the LUB and this one, yeah.
Yeah.
So so this is the case right now in the Scala 2 compiler.
Yeah.
And this looks very much like a fixed point problem, right? You have a container of a container of a container. You're trying to find what the inner type is, right?
Yeah.
How does the compiler resolve it right now? Like is it just it goes? So
yeah, you can just try it. You can just type this code in. I think it says basket of any. I've seen it actually go a couple levels sometimes, so I'm not sure how perfectly if it picks the top one. But what it does is it doesn't go into an infinite loop and blow up because it runs out of memory anymore. It just picks one, but it's not the least upper bound. But it is an actual correct. It is one of the super types. So I think when I pasted this code in, this code here, it picked basket of any. And I think it just notices that it's like has this problem and it just special cases hit.
So that's an optimization in the compiler then?
Yes.
Oh, okay, gotcha. Thank you.
Yeah, Martin told a story once where he was in an audience and someone showed how they could get both the Java compiler and the Scala compiler to blow up on stage. So anyway, it's a very corner case, but it's just annoying that that it's there, and so that's one of the things that you wanted to fix in Scala 3 rework. So okay, anybody else? Move on.
Yes. Yeah, one more.
Sure. Yeah, go ahead.
Just with your variance examples there, you've got covariant and contravariant examples. What happens if you have one that's parameterized by, say, a covariant and an invariant?
You mean more than one type parameter?
Yeah.
It would look like this, except for each one of these. So the covariant one would kick it into this kind of shape. But the invariant one would mean that for each one of these, you'd have an infinite number of types that are unrelated to each other than this relationship, I think. That's how that would work. Because when I say show of t, see how I get an infinite number of these? So that would be a second, like u, like basket of plus t comma u. For every one of these little basket of somethings, I would actually have basket of fruit, comma any, basket of fruit, comma fruit, basket of fruit, comma plum, basket of fruit, comma apricot. And those are all, all the basket of, like, basket of fruit, comma plum, let's say. Basket of apricot, comma plum is going to be a subtype of basket of fruit, comma plum. Because they have the identical U type. But you're not going to get any other structure than, it'll look like this. You'll just get a lot more types. It'll be multiplied by infinity.
Yeah, that makes sense. What happens if you had a covariant and a contravariant
like function one
at the same time?
Function one, okay. Can I take that as a homework assignment? I have no idea.
Sure.
That's going to be interesting because you have to merge this one and this one. Okay, that's a real good question. They get kind of hard to draw after a while, but I'll
make
see if
a
I can figure that
pattern.
out. Yeah, they might make a beautiful fractal or something. I don't know. That's a good question. So I'm going to write these down because I don't want to forget. So do not forget. Because I already forgot the first one. So the second one is diagram for plus t minus u. And what was the first one that I was going to find out the answer to? Is yeah, serializable product. All right, but that'll be enough to remind me. Okay, anyone else before I venture forth?
Yes.
Yes, go ahead. Yeah, sure.
In the case of the basket of nothing,
yeah,
does it have any inhabitants, or is it equal to it's empty also?
No, basket of nothing can have an inhabitant. Yeah, like an empty basket is a basket of nothing. Like an empty list is a list of nothing.
Okay.
The basket can't have anything in it, but it can. The basket of nothing type has the inhabitant empty basket, or maybe that's an infinite number. You know, you can maybe make an infinite number of those. There's no reason you couldn't. Yeah.
Thanks.
Sure. Okay. Should we move on? You got another one? Yeah, that's fine. Go ahead.
So isn't list of empty a value rather than a type that satisfies the list type?
Yes. I think what you mean is nil is a list of nothing. So if I say list.empty, that's list of nothing. Oh dear.
Oh, gotcha. Okay.
Sorry, I think I've got one too many things going. Well, this whole shutdown thing is the time to pause and reflect. There we go. See, they had to think about things. Yeah, so basket of nothing is kind of like this. You could not put anything in that basket, but you can certainly type list of nothing has an inhabitant because nil is one of them. Actually, it's the only one. This is singleton, and list is sealed. All right, anybody else? Going once? Yes, thank you. Okay. All right, let's move on, and we'll stop again. So the next subject is about parametricity. Really, it's what here this termed as is parametricity because that came from Haskell. There was a paper by Phil Wadler called "Theorems for Free," which showed that if you just have a type parameter and don't say anything else about that type, you can actually prove a bunch of things about it without knowing anything about what the method does. That was called Theorems for Free, and what it means in practice is if we use type parameters, it really limits our ability to get something to compile, which means that it limits our ability to get it wrong. Like there's fewer mistakes that can compile. In Scala, because we have type system, I think of it as subtyping. I kind of think of it, I call it any-icity, or I think of it as it's really about any. Because any is the most abstract type we have. And as you go down the hierarchy, you get less abstract and more specific. And there's more information the more I go down. Like if I have a plum in my hand, I know a lot more about it. I can do a lot of things, plum-like things with it because I know it's a plum. Whereas if I have an any, I don't know what it is. And type parameters by default, if you don't put any bounds on them, are type any. That's all I know about them. So nothing is a weird kind of exception to that rule because it's not an extend subtype. So like as I go down the hierarchy here, any ref extends fruit. I'm sorry, fruit extends any ref, plum extends fruit. You add more stuff, right? It becomes more, there's more information there. But when I get to nothing, because there's no inhabitants, you don't need, that's that special thing of an empty set. It can be a subset of anything else. It actually doesn't need to have any of those methods because you can't ever have an instance of nothing to call any of those methods on. So that's why it's a special case. So it's sort of like it has no information again at the bottom, kind of loops around. But an example of it is simply this, where if I have a basket of, I want to put a map method on my basket, and I said, actually my basket can just have one thing in it currently. It's like a cell that can contain wrap another object. I call that A, and it's type A, big A. If I want to put a map method, just kind of like the map method on list, or sum. Actually, this is just like sum. So the B in the type parameter B there on the map method means that anytime anybody calls map, there'll be a B. There shall be a B that will be either explicitly given, but usually it's just inferred. And then I got to pass in a function from A to B to my map method, and I'll get back a basket of B. So inside this class, there's very few ways I can, non-evil ways I can get this to compile without it being, that aren't correct. So like one of them you're staring at, which is triple question mark, which is throw an exception, right? Because the type of throw is nothing, because it doesn't actually return a value. It throws it on some other channel. And so that's one way I can implement this, but it's kind of obviously wrong. The other way is basically I have to do this. I have an A and I have a function from A to B, so I'm going to have to pass the A to the function f. So I say f of A. Now I have a B, and I have a constructor here where I can create a new basket of that B, and that's my basket of B. And that's really the only way I can do it, because I don't know anything about A, except it's in an any, right? It's anyicity. So I get abstraction on the inside like that that helps me reduce errors. But at the call site, like every call site is different, but this call site I happen to put a pluot in my basket. I know it's a basket of pluot, and that's exactly what I want to do, because when I take that out, I want to know it's a pluot so I can do pluot things with it, right? So we can, subtype, supertype is how Scala does this abstraction where we want it, where we get the benefit of like not knowing anything about it, and then concreteness, or the opposite of abstraction, where we want it, which we also want that. Like when we put pluots in a basket or a list, and then later we take them out, we want them still to be pluots. We want to keep remembering that. So anyway, that's, I think, pretty fundamental to Scala. And then another reason it's kind of good not to call it parametricity is because we also have type members instead of type parameters. So we're talking a little bit about type members along these lines, because they're very similar. And the motivating example is I went back to my C programming book because I couldn't remember the syntax, and I found this thing where it had a file in it. This is opening a file. When I open a file in C, I get a pointer to a file, big F, big I, capital F-I-L-E, which was a type alias. And then I get that back, and then when I want to get a character or get a string, I call fgets. I need to pass the file in to say get it from this file, and then eventually I have to remember to close the file. I just pass that to fclose, right? So if you look on the documentation for this type, which is like a type alias, one of the things it says is the content of a file object is not meant to be accessed from outside the functions, the standard library functions, right? And that is always a bad smell to me, where you're telling somebody that here's a bunch of really interesting things, don't touch them, right? It's like a sign that why did you design that such that I could touch them? It should be not something I can touch, right? So what you can do in Scala to prevent that is make a abstract type. So an abstract type is what we call a type member that has no definition, right? So when I say trait standard IO, I can have type file, and my fopen can return that. My fgets can take one, and my fclose can take one, right? So a similar kind of structure, but I've made it abstract. And what that means is that the caller can't do anything with it because they don't know what it is. It's just kind of like when I couldn't do anything with an A because I didn't know what A was, or B because I didn't know what B was, and the previous.
Did we lose Bill?
I was blaming my own computer, but I'm glad you asked that. I think so. Bill, can you hear us?
Yeah,
I was
I think
checking
we
my
lost Bill.
connections as well.
Yeah, I lost as well.
Maybe it's that mosquito that finally got its way.
Yeah, give him a few
No.
because it's probably just redialing.
Yeah, he's dropped off, so I assume he's going to rejoin.
Well, you'll have to do some editing in the video.
No, it's real-time TV, dude. Whilst we're waiting for Bill to come, if anyone wants to do a talk at a future SF Scala meetup, please do get in touch with me. And also, let's talk more between meetups on Slack. Good to keep in touch with everyone.
Yeah,
How's the job market out there? How's the job market out there? Are people hanging out at their jobs, or what's going on?
Sitting happy.
You ran out of battery, didn't you, Bill? You wanted to break, right? Battery? Yeah. Sorry about that. I hadn't noticed my power adapter was had become unplugged, so I ran out of juice. But I will continue. Oops. Uh-oh. Somebody needs it.
Eric, you probably need to make him co-host again.
Sure. Whoever can make me a.
You should be able to.
Right. Oh yeah, I see your co-host now. You're all set, Bill.
Co-presenter.
Yeah,
that's perfect. Keynotes. Oh, that's not that one. It is. Hang on a second. Keynotes. Go here.
The birds chirping are
just
very
for the moment. Set up my keynote further so I can share it. Well, here it is. SF Scala. All right, and we were here, right there. Share my screen. Okay, let's see if I have. There it is. Okay, now we're back. So can you hear me? Can somebody unmute and just make sure that you can hear me before I go forward?
Yep. You're good.
Yes, we can.
Yep, we can hear you and we see your presentation slides now. Oh, good.
Anybody hear me?
Yep, perfect.
Oh, I know what the problem is. I can't hear you. All right.
Yeah, probably.
Okay, that's it. My volume got turned down too. All right, well, that was a reset.
Yeah.
Okay, I will continue then.
Welcome. Yeah.
So, essentially, when I took a break, I was talking about this kind of type here, which is called a type member. If it's just sitting there, it's an abstract type. It doesn't have any bounds or it's not defined anything. And so this is where I was. Essentially, at the, inside standard IO, it's kind of like the A inside basket, where there's a type that exists, but I don't know anything about it other than it's an any. So right up here, like fopen, when I implement fopen, well, I can't implement fopen here because I don't know what that type is. Down in the subtype, I can fix it to something, like I created a file handle case class here, and I have fixed it to file handle. So now I know exactly what it is. So it's kind of like, when I created a basket of fluid, I know that the basket contained exactly fluids, right? So where I want it abstract, I have it abstract. Where I want it concrete, I have it concrete. But what's nice about this is that if someone calls my get a standard IO class, it just returns standard IO. And at the level of abstraction of standard IO, we don't know anything about file except that it's an any, right? So we can't do anything with it. So that's why we don't need that kind of documentation like this, where it's saying, please don't mess with the file object. You can't mess with the file object, this one, because you know, it's an existential type. We know at the standard IO level, where you're inside the trait or outside of it, you know that there is a file that, you know, a type that exists, but we don't know what it is, other than it's an any. So you can do the same kind of thing. Basically, you get the same thing this way. So there's kind of two ways to do the same thing in this respect in Scala. I could, instead of using a type member, just use a type parameter. And now in the subclass, I just say, you know, down here, private class, and then I actually go this way so I can point to it. Private class substudio standard IO extends standard IO, and here's where I fix it, right? So again, inside here, I know what it is. It's a concrete type, just like before. To get the same kind of existential type with the client, I'd have to use a wildcard, which in Scala 2 is actually an underscore. So currently you would write that in Scala. But in Scala 3, they want to change that to a question mark, which I think is kind of prettier. So I'm going to use that one here. This is what it is in Java. Java's wildcard is a question mark. And they want in Scala 3 to make the underscore kind of mean the same thing at the type level that it does at the value level, which is like placeholder notation for things. So anyway, they're going to change it to question mark. And so that's sort of the corresponding kind of parameterized type to the abstract. It's a standard IO which contains an abstract type. So, but you get the same thing. So the other thing I could do with, of course, a parameterized type is I can say, well, I don't just return any old standard IO here, right here. I've changed this. I return a standard IO of file handle. So now the client knows exactly what it is, and maybe I need to make a comment saying, hey, don't touch this. But really, if I really, you know, in this case, if I'm doing this, I probably want them to be able to touch it or something. Otherwise, you wouldn't give it to them. So the question then is, how do you do this with type members? That is called a refinement type. So I made it pink here. What I can do with a you know, the standard IO that has type file as a member is I can, this whole pink thing right here, this guy is called a refinement type because standard IO is sort of a type. I refine it with what's in these curly braces, which is more information about it, something that narrows it to make this, you know, the set of inhabitants smaller. Here, it's not just any old standard IO, it's a standard IO whose file type has been set to file handle. That's called the refinement type. And that gives you the same thing as the previous slide with type parameters. So in summary, for these guys, you know, the you know, standard IO with a type file member is, the file is an existential type at that level in the sense that it has a, you know, there's some type there inside there, but we don't know what it is. It's known by the subtype, and I don't know what the subtype of standard IO is. You can do the same meaning with standard IO underscore currently in Scala 2 or standard IO of question mark in Scala 3. If you want to fix it, you use a parameterized type on the left-hand side and a refinement type on the right-hand side. And then I can actually even make, you know, like concrete types below that are, you know, the ones I made on my previous slides where I said class, private class, standard IO extends standard IO of file handle. That was the left-hand one. And then on the right-hand side, I just extended standard IO, but inside my body, I made type file handle, file equals file handle. So I think that's that one. So does anybody have a question about that part? Type members and abstract types and refinement types. I guess one other thing I would add is that I wasn't going to talk about what we call structural types in this talk. Structural types are refinement types on any. So right here, you know, this is a refinement type on standard IO. If that were an any, you could just leave it off, and that's called a structural type. It's a refinement type on any. Just means it could be anything with a, you know, a method or whatever you put in there between the curly braces. So anybody have a question about that? Okay. Well, if not, I can continue. You can go back and ask about it later if you like. So the next thing I want to do is talk about bounds. Bounds really was difficult in the sense of lower bounds, I guess, especially. upper bounds, there's a lambda calculus variant that like systemf sub that sort of has a soundness proof and everything. But the Scala has lower bounds also. And so lower bounds really throws a wrench in the works because people can make the lower bound above the upper bound, which makes it an empty set. So it's like bad bounds. Whereas I can't really do that with when I use extends, the compiler will check to make sure it makes sense. I can't have, fruit extend plum and then find plum extends fruit. It won't compile, right? But I could actually make bad bounds. So that's part of the Scala 3 project, was to figure out how to make a soundness proof with lower bounds. And that was, I think, a kind of an intellectual achievement of that of that work, because I think they figured that out for the first time for anybody. But anyway, so if I have my trait show of t, and I'm going to start using the wildcard one here, where I say show of question mark. What show of question mark means, it basically kind of means the same thing as show of any. It has the same inhabitants, because that question mark can be filled up with anything. It's just I don't know what it is. Whereas show of any, I know it's an any. But of course, since any type is any, I do know it's an any. So it sort of means the same thing. And it also means subtype of any. So anytime you don't have anytime you don't have, can I get rid of my, go to here so I can use the mouse. When you don't have an upper bound on your wildcard type, it means it's a subtype of any. That's what it means. So if you see show of question mark, that means show of question mark subtype of any. And show of question mark subtype of any, show of fruit is actually one of them. Show of plum is one of these guys. So you can see these are the sets. This is a set of show of fruit. This is a set of show of plum, set of inhabitants. And they're inside the set show of question mark, because, is a plum an any? Yes, so that means that, it is one of those. Show of question mark subtype of fruit, that means anything that's a subtype of fruit, is a member of that type. So show of plum, again, is a show of question mark subtype of fruit, because plum is a subtype of fruit. You plug in plum for the question mark, and it is true, so therefore it's part of the set. So you can see everything inside this yellow circle is a show of question mark subtype of fruit. But show of fruit is just in this circle, because a show of plum is not a show of fruit. Remember, these are, show is invariant. So there's no, just because plum is a subtype of fruit, that does not imply any inheritance relationship between show of plum and show of fruit. They're invariant. So that's sort of how it looks. And you go down here, this one is the show of nothings, which they do exist, right? You can create them. And then over here, this is kind of the hierarchy that maps to that Venn diagram. So that's invariance. So what covariance looks like when you use upper bounds, this is just showing upper bounds, is what happens is basket of any, now there's an inheritance relationship. A basket of fruit is a basket of any because of covariance. So you see these little circles right here, like this one, this one, this one, this one, they go away. And now basically basket of any means the same thing as basket of question mark subtype of any. So that's actually how you can relate variance to bounds. And in Scala 3, that's what, basically the type parameters are redefined in terms of type members. They'll rewrite a type parameter at some point to a type member with a fictitious name, or they make up a name, synthetic name. And so that's how they, when they rewrite something, a type parameter that's covariant, they're actually going to put a bound like this on it. So anyway, that's covariance one. And then invariance is kind of cool. It's inside out, right? Because remember how an eater of fruit is a subtype of eater of plum. So you can see it kind of goes this way, and the one at the top is eater of nothing. But it's this sort of symmetrical. It's like the inverse or the dual of the other one. So that's, this is, except I did make one difference here, is these are now lower bounds, right? This is eater of anything that's a supertype of nothing, which means like if something eats nothing, you can't pass, if something requires an eater of nothing, that function cannot pass anything in there. So it's okay to pass an eater of pluots, an eater of plums, eater of fruits, So that's why an eater of anything that's a supertype of nothing is on the outside here. So again, when Scala 3 rewrites type members to type parameters, this type parameters to type members, this is the sort of what they do with it. They'll put a lower bound on it. Okay, so so this is kind of the same thing. This just kind of shows that you know, types with the square brackets are parameters types. Type with question marks are called wildcard parameters. And this is a Scala 3 syntax. The Scala 2 syntax is the same thing with an underscore. But it's kind of like subtype relationships between these kind of bounded types with upper bound, lower bound. You can think of it as interval inclusion. You can just sort of think of it as sets, right? Pluot to fruit goes from here to here, right? That includes plums and apricots. This one goes from pluots just to plums. This one goes from plums just to fruits, right? So this guy includes a smaller, well, it's like a subset of this. Because this goes from pluots to fruits, it's going to include just the plums to fruits, right? So that's why this is a subtype of that. It's interval inclusion. If you include, you know, if this interval is included in this one, then this is a subtype of that one. That's essentially how that works. And if you, again, try to map, I just took the same thing, the same hierarchy, I just put it on a Venn diagram. So it looks, this actually looks like the one, the first one I had with the little circles, you know, inside here. And the reason I wanted to show this is I wanted to show you that for everything you can do with these wildcard types and bounds, you can do with refinement types. So here I've just, you know, sort of mapped a wildcard type into a refinement type with bounds. And the intervals are the same. The subtype, supertype relationships are the same. And even this diagram looks the same, except I had to make them wider because they're longer horizontally. But it's the exact same relationship when you use bounds. So bounds, if you know, like subtype, supertype relationships are implied between bounds when the, you know, the subtype, like set of inhabitants is included in the supertype set of inhabitants. So that's a big one. Does anybody have any questions about that one? Upper bounds and lower bounds?
So question, so you mentioned that there are intersection types in Scala 3.
Yes.
Do the intersection types themselves have bounds, or the intersection type itself is bounded at the compiler?
The intersection type can, well, let me scroll back to that one slide, and I think it's easier to say it with that in front of me. This one. So like this is an intersection type, this is a union type, either one is it's like any two types can be intersected, any two types can be unioned. So I could take a like, you know, question mark subtype of fruit could be over here, or plum, something like that, right? I mean, I can union any two types, I can intersect any two types, and I get a new type. But there's nothing special. You can't like put a bound on ampersand.
Gotcha.
Yeah.
Gotcha.
Okay. Any other questions about bounds?
So this is just one question that, you know, more like dealing with legacy Java libraries and how like they expose the APIs. So is it, like, in your experience, is it better to use type, the member type, the abstract types, or like bounds?
Oh, well,
or like just go with type classes?
It's well, type parameters. Yeah, type parameters versus type members is still a good question, like design question. One thing you can, like, a couple differences. One thing you can do with type members is path dependent types, which you can't do with type parameters because they're kind of like private. And then the other one is higher kind of types are about type parameters. So if you're going to do things like, you know, implicitly looking at monad type classes, you're going to use a parameter. I'm sorry, yeah, a parameter. So there are some differences, but that's what I would say the difference is. Like just at, like with looking at like what I showed you, isomorphic. Everything I can do with a wildcard type, I can do with a type member. And in fact, in Scala 3, they just rewrite type parameters to type members internally in the compiler as they compile along. But there are some differences in that would, like, depending on what you're trying to do. Certainly, if you want to do a dependent type, you would use a type member. And if you wanted to do something that, like with hierarchy types, like you can say my monad takes an F open square bracket underscore close square bracket. That you can't do with type members. Excuse me. So both of those are useful. Any other questions? Okay, well, we can go a little further. I've got 2 more Q&As and we're done. But they're only 2 slides each, so we're wrapping up here. The next one is just one concept, which is singleton types. Sorry. So going back to my traffic light example, where I have 3 objects, red, yellow, green. The dark red circle, like this dark red circle, this dark yellow circle, this dark green circle, that's kind of bright green. Those are the inhabitants, right? That's a value, and there's just 3 of them. But these like circles that are faded are the types. So there's 4 types. Traffic light is one type. Yellow dot type is the type that contains only one instance of, well, it contains object yellow, essentially. Red dot type is the type, it's the set of all, which is only one of them, red objects. And so what dot type here means is if you have a singleton object, that's actually a term. I can say red, and it's actually, you know, I can print red. You know, I can pass red to something that takes a traffic light. It's a value. If I say dot type after this term, it turns it into a type. That means the one and only one object that that guy points to, which is a singleton. There's only one of them, because this is never going to change. Right, the compiler ensures that there's only one singleton red. So that actually maps to a singleton set. So here you can see this set named red.type has one element in it. That's called the singleton set. And that's why we call it a singleton type in Scala. And you can also do it with vals. So if I said val x equals high, and then y equals x, both x and y point to the same object. So there's really just one, and they, as far as singleton is concerned, you could think of them as the same type, right? But the compiler can't tell that at compile time. So what it does is says, well, I know x will always refer to the same string because it's a val, and the compiler ensures that, enforces it. Y will always point to the same string. I don't know which string it is, because it's a val, right? So x.type and y.type is a subtype of string. And they're 2 different types in Scala's type system, even though they actually happen at runtime to point to the same object. So here's x.type, and here's the string high. That's a subtype of, you know, it's a subset of the string set, which is infinite. So that's called, those are called singleton types. Any questions about that? Singleton types? Check Slack. And they're subtypes of the type of it, you know, the thing. Like this guy, this type was a red.type is a subtype of traffic light, and x.type was a subtype of string. Yeah, go ahead.
I'm curious what use case that this would come in.
Well, now, one use case I've seen it used is DSLs, but the main use case I think is concept types, which is my last one, which I'll show next. Okay. Yeah. So any other questions about singletons? Yeah. So, okay. So last 2 slides is this. So first of all, so many types of types. One of the things Scala did is it got rid of statics, right? So in Java, for example, you have static methods, which are different from instance methods on a class. So I could have a class outer, and it could have static methods and instance methods. But in Scala, class outer, you know, I can create instances of, and then where I would put my static methods is I would put them in object outer. So object outer, you know, this outer here is actually a term. It's the name of it's almost like a val, like a reference that points to the one and only one instance of this object outer. Class outer is a class, it's a type, right? Because a class defines a type. Outer.type is a type with this guy. but this is just outer, because that's a singleton, give me a singleton type, outer.type. This class gives me a type. So those are two different things, but they have the same name, and they can both have nested types inside of them. So here I've got an inner class. Well, the inner inside this outer is a type, and here I've got a type member. Well, the inner inside this outer is a type, right? So how do you differentiate them? Well, it turns out that if I use a dot, that means that the thing to the left is a term, which means it's a name that refers to one and only one object. It has to be either a val or a singleton object for this to work, for you to be able to use this. And that's called the path. So this is like a path dependent type, because I have a path to get to this inner, and everything leading up to the last thing is always a type. Everything leading up to it is a term. So it's either a val or a singleton object. And I can say a.b.c.d.outer.inner. And even the package names, you could think of packages as singleton objects. So they're also stable. So those are part of the path, really. Whereas this guy, they call this a type projection. So one of the reasons they need to have this £sign keyword is, well, I just used the dot. And this in Java would be a dot, which is you select a type inside a type. So what the £sign means is both of these are selecting a type inside something, but the dot, you're selecting the type inside a term, and the $, I'm selecting a type inside another type. So this one is the inner type inside any outer instance is what that means, and that would be outer.inner in Java. So that's called a type projection, because projection just means selection. I'm selecting something inside something else. So here I'm selecting a type inside a type. So that's a type projection. This would be a term projection, I guess. But anyway, with this class, here's what I can do. I can create two new outers. I'll name it outer 1 and outer 2. And then I can, with those two references, I can create two new inners. This is a new inner inside outer 1. This is a new inner outside outer 2. And the type of this guy, remember, the type of inner 1 is outer 1.inner. The type of inner 2 is outer 2.inner. And those are subtypes of the type projection. So that's, I mean, this one, when I came to Scala, it was just like one too many symbols. It was really hard to kind of like, oh my God, what's this one? Type projection. It just means I'm selecting a type inside a type. And it's kind of, you needed this other character here because we ate this one, we ate the dot, so we couldn't use it for this. And this is useful still to have. But this is a path-dependent type. This is a path-dependent type. Here, remember, the dot means the thing over here is a term. In this case, the term is a singleton object. In this case, the term is a val. Oops, sorry, val, outer 1. Here's the outer 1 val. So anyway, that's type projections and path-dependent types. So what is actually useful about path-dependent types is that you can actually refer to them. And this is like puts all this stuff together about subtyping. So what path-dependent types in Scala do is use subtyping to actually get sort of dependent types, sort of, but without, in a different way. So what I have here is I can have an example method that takes an outer. That's an instance. Remember, this is actually the type I get with class outer, right? Because if this were this, if I were trying to say you gotta pass me the singleton object, it would have to be outer.type. So anyway, there's this, I'm taking an instance of outer and I'm saying you're gonna return the inner inside that thing. And of course, at this point, I don't know what that is, right? But maybe there's some methods on here that I haven't shown that I can call that will give me one, right? Whereas here I've made a, oops, I forgot to say extends. Sorry, I made a mistake here. Extends outer, forgot that important piece. So this guy extends outer, he's a specific outer, right? And he fixes it to string. So where I pass in specific outer, the compiler looks and says, oh, at this call site, the outer is the subtype of outer where inner is fixed to string, therefore outer.inner is string. So it knows, like in each call site, it will figure out anew what this type is. It depends on the specific subtype that's passed in at the call site. That's how path-dependent types are used in Scala. And so what I would say is that it's a nice feature, but it's actually not necessarily needed, because you can actually do the similar thing with this. if I were to say at every call site, I could define my example method this way, where I take a T and I say, well, T is going to be inferred at every call site, and it has to be a subtype of outer, right? That's kind of saying the same thing as this, because you can pass any subtype of outer here. And then I'm going to say it's whatever that subtype is, the inner projection on it. It's like the type inside that subtype. That actually means the exact same thing as this. That's what path-dependent types mean in Scala, is type projections on the subtype. And really it's it's sort of where singleton types come in, is because the specific subtype is the singleton type of the whatever you're passing in at the call site. So here, this is another way to write this guy, is I could say, I take an outer, and then it's a type projection on the singleton type of whatever this guy was at the call site. So that's sort of maybe a thinker, but that's another way to write, this. And this is just almost like syntax sugar for it. And in Scala 2, we still can't do this kind of thing with constructors, I believe. You can only do it with methods. In Scala 3, they fixed that. But it's really just almost like syntax sugar for doing this. It's a single type, a type projection of the thing that you're depending on. So that is my whole spiel. The only thing, I went through every type of type, I think. I guess I didn't do opaque types in Dotty. Well, I went through every Scala 3.2 type, except for higher kinded types. So that's all I got. Does anybody have any final questions about
If you
this?
go back one slide, Bill.
Sure.
Just to 55.
Oh, sorry.
Right. So in the last def example, without the type annotation there, so I'm confused about outer.type.
Yeah.
So the outer.type is the type of the singleton, though. So
yes.
why is it hash inner then?
Because if a hash means that the thing to the left is a type, right? So.
Oh, right.
Remember, yeah. And so really this is another way to do it, but it doesn't look the same because I have to have a type parameter, right? But it actually would give me the same benefit. Inner depends on what T is, what subtype of outer it is. But this guy here, he doesn't have a type parameter, and it actually means the same thing. It's how I can turn a dot into a pound sign, is I use the singleton type of this. And in the compiler, I think they switch it to this. They just use the singleton type and a pound sign, because that means the same thing.
Okay, and then on the previous slide, 54?
Yeah.
So the outer one dot inner in the diagram?
Yes. This one.
It is outer one dot inner.
Oh, I'm sorry, outer one dot inner. This guy, yes.
Right, so that's a subtype of outer pound inner, but
yes.
outer pound inner is the nested class inner, right?
Correct, yeah.
But the outer one dot inner is the singleton.
Oh, no, because outer one was a new instance of this class, right?
Oh, right, okay.
Yeah. So he's more specific.
Oh, right, okay.
Yeah.
Yes, got it, thanks.
Yeah. Yeah. So, anybody else?
I'm puzzled. Why is that a subclass? Isn't it the same class?
Well,
because we are not using the object outer where the inner is defined to be a specific string. In the outer class, the class inner is still, so isn't outer one dot inner the same class as outer pound inner?
It's more specific. So the reason it's a subclass is this one only has one. So outer one is a val, so it refers to this guy. So that's like, you could think of it as, yeah, I guess I could rewrite it. I'll just make it do this. I'll show you. The other way you could think of this one is outer one dot type. That's a type now, pound sign inner. So you could say it's, there's only one singleton instance of this instance here that I've created is referred to by this val, this will only refer to that one. So it's a singleton type, outer one.type. The type projection inside that, well, yeah, it's a same class, but it, there's only one here, there's one here, but this guy has both of them because this is any instance of inner, inside class, outer. So this is one and that's another one. So that's why, the reason it's a subtype is this is a singleton, this is a singleton chet, and this is not. This is more general. It's a super
Okay.
set. Yeah. So anyway, anyone else?
Thank you, Bill, for a fabulous talk and
Okay.
Q&A session. We learned from you on how to do Q&A on a virtual meetup. So thank you so much for that.
Yeah, you know what? I just kind of thought of that. We're all figuring this out as we go, but yeah, that way. Yeah. So anyway,
really superb talk from both yourself and Pierre. So thanks so much for both of you for taking the time to do this. Yeah.
Yeah.
Of course, conversations can continue on Slack, and I didn't make the mistake of last time. I did bring wine to the ending of this one for a happy hour, even though my wine looked to disappear. See?
Yes, it does like to disappear.
Yeah. But and if anyone else wants to do a talk at a SF Scala meetup, or knows anyone who wants to, please get in touch with me. But of course, I'm on Slack. But otherwise, thanks for everyone who attended also. Thank you for taking the time to attend one of our events. Anyone want to talk about anything else before we sign off Zoom? Of course, the conversations on Slack can continue indefinitely.
Just a comment, I'm consulting with a company called HPE right now. We've got some openings for Scala hackers. This particular team is deep into Scala, so they're trying to get into functional programming and effects-based programming and so on. They're looking for hackers as well as an architect. Thanks.
Irfan, if you get a chance, advertise the role on the jobs channel on Slack. We actually created a jobs channel to facilitate the hallway jobs thing of a real meetup.
Got it. We'll do. Thanks.
Yeah. It doesn't hurt advertising there either. Thank you. Anyone else? Anything? Demandbase, Eric and Leo, thank you so much for hosting us. And really appreciate you guys taking the time and providing us with a Zoom facility and helping us with running it.
It's our pleasure. We recorded. We'll make the recording online available to you to post.
Thank you.
Looking forward to more in the future and hopefully more speakers too.
Thank you. Thank you. Appreciate it.
Thanks, Bill.
Really appreciate it.
Yeah.
Thanks, Bill. Thanks, Pierre.
Right.
Thanks, everyone.
Thank you, guys.
Thank you all.
Bye. Night, everybody.
Bye. Bye.
Bye.
Bye.